Okay. Jackie, break down 36 for me. 6 and 6 would be a good start. 6 isn't prime, but we know from over here, 6 is going to break down as 3 and 2. Okay, so that's step 1. Now, the rest of the steps beyond creating the factor trees are over there for you. Right, the next step is to write the factorization with the powers. Okay, so this is unlike greatest common factor where you couldn't. Now you're supposed to. So for 24, we've got 3 2's, 2 to the third, times 3. For 36, 2 2's, 2 3's, 2 squared times 3 squared. Okay, so that's the second step. Now, the next step says we're going to go through and we're going to circle the highest powered exponent terms if they have like bases. If they're just solo, it'll be that one. Okay? So, what I mean is, right, the things that start with the 2 are 2 cubed and 2 squared. The biggest one is 2 cubed. So 2 cubed I'm going to circle. That's going to go with me to the answer. Of the things that start with 3, I have 3 and 3 squared. 3 squared is the biggest, so it's going to go with me to the answer. Okay. Now, all you got to do to finish is you're going to multiply together the circled terms. So I'm going to multiply together 2 cubed and 3 squared. 2 cubed is 8, 3 squared is 9, 8 times 9 is 72. So the least common multiple of 24 and 36 is 72. And yes, we'll do another, so don't panic yet. Part B, we're finding the least common multiple of 6 and 20. Right? You're familiar with the first part. You should be very comfortable with this by now. Factor trees of 16 and 20. Okay, break down 16. 4 and 4. I'm glad you said that. Ashley, how's 4 going to break down? 2 and 2. All right. Break down 20. Jackson. 5 and 4. Now, 5 is prime, but 4 isn't. But we just said over here that 4 is going to break down as 2 and 2. All right, so that's our factor trees. All right. The next step, I have to write the factorization with the powers. So 16 is easy, just 4 2s, 2 to the 4th. Over here for 20, I've got 2 squared, and I've got 5. So we can compare the things that start with the 2's. I've got 2 to the 4th and 2 squared. Which one is bigger? 2 to the 4th. Now, even though 5 doesn't have a match, it's still the bigger of its column, okay? 5 or nothing, 5 is obviously the bigger of the 2. So 5 is also going to go with me to the answer. It doesn't necessarily have to have a match. So, I've got everything circled out, so I can multiply. 2 to the 4th times 5. Which is the same as 16 times 5, and 16 times 5 is 8. And obviously in the homework tonight, you'll follow whatever directions they give you for those type of problems. If it says to list multiples, you'll list multiples. If it says to use prime factorization, then you're going to be making a bunch of factors. All right. Let's go to example 3 then. Example 3 is the last thing we have to do here today. It's the least common multiple of monomials. Least common multiple of monomials. All right. Now, as far as the number part goes in these, the number part's going to be done the exact same way. All right. So there's no real trick here as to how we start this. All right. In part A, we're finding the least common multiple of 6x squared y and 9x to the 4th z. So let's do the 6 and the 9 with with the factor trees, and then we'll do the other one with just listing. Breaking these down is not a difficult thing. 6 breaks down as what times what? 3 times 2. 9 breaks down as 3 times 3. All right, so 6 I've got 2 times 3. For 9 I've got 3 squared. All right, so let's start with the 2. What's bigger, 2 or nothing? 2. What are the 3's? What's bigger, 3 squared or 3?
3 squared.
3 squared. So I have what I need to multiply together. I've got to multiply together 2. Is that a question, Elaine?
Yeah.
Go for it.
Wouldn't you circle the 3 because it's bigger than 2?
3 squared is bigger than 3. 3 squared would be equal to 9.
But the top would circle 3 though, right? 2 times 3.
It's not the biggest in each row. It's the biggest going this way.
Oh,
Okay? All right. So I've got to multiply together the 2 and 3 squared. 2 times 9 gives me 18. All right. Now, as far as picking up the variables go by the same rules as the factor trees do. We're going to take with us the highest powered ones. So here I've got x squared. Here I've got x to the 4th. Which one's bigger?
X to the 4th.
That's going with me to the solution. Here I've got y. Over here I don't have any y. So that's not a trick. That's just going to go y. Here I have z. Here I don't have any z at all. Z is bigger than nothing. And there's the least common multiple. So do the numbers the way you would any other method. And then when you get to the variables, you just pick up the highest power. All right, let's try that one more time, because I see there is some confusion. So 4ab squared, 10a squared b. Least common multiple of 4ab squared and 10a squared b. All right, so let's start by listing multiples of 4 and 10. All right, let's start with the ever tricky number 4. Drake, give me some multiples of 4.
2.
No, multiples, not factors. Start with 4. Then go to 8.
8.
Okay.
12. 16. 20. 24.
Okay. Now we've got to do the multiples of 10, which is an even trickier list. Brooke, multiples of 10.
20.
Starts 10, goes 20. We can stop because we already have a match. So as far as the numbers go, 20 is our number. All right, now let's do the variables. I've got a here. I've got a squared here. Which one's bigger?
A squared.
A squared. So that's going with me to the solution. B squared or B?
B
Which one's
squared.
bigger? B squared. That goes with me to the solution.